Hi everyone. In this tutorial, I'll explain how to use a LINEST function to interpolate a set of data which are linearly related. LINEST function can be used in two different ways. You can get the minimum data, that is slope and intercept, using the LINEST function, or you can get additional regression statistics. So first I'll explain how to get the slope and intercept for a given set of data. So LINEST function can be used to find out the slope and intercept, and then you can use that slope and intercept to interpolate and get the values of data which are not tabulated. So here, to use the LINEST function, I have written slope here and intercept. So I'm going to get the values of slope here and intercept here. When you use a LINEST function, you need to select two cells together. So I'll select these two cells where you require slope and intercept. Then after selecting those two cells, I should type the formula equal to LINEST. Select LINEST function. Okay, then you have to select known y values. So here I have a set of data which is temperature and thermal conductivity of material. So thermal conductivity is varying with the temperature. Thermal conductivity is the y value, that is dependent variable, and temperature is the independent variable. So the target variable is thermal conductivity. You are finding out how the thermal conductivity is varying with respect to the changes in temperature. So thermal conductivity is your target variable or dependent variable, and that will be your y value. So I am selecting the known y values, and then comma, known x values you can select. Then you can close the bracket, and we need not give any other parameters. You can close the bracket. Now before entering, you have to hold down the control and shift. You holding the control and shift down, you can press the enter key. Okay, not just enter key, control shift enter will give the result. Control shift enter. So that will give the slope and the intercept. So you're getting the slope as minus 0.4 and intercept you are getting. Now I'll use that slope and intercept to find out the thermal conductivity. So I am using this equation y is equal to mx plus c. So this is a linear regression model. So the simplest form of LINEST function, it's only used for linear interpolation. So I've done only linear interpolation. I got slope and intercept. Now I'll use this slope and intercept to find out the thermal conductivity for any other temperature within this range or slightly outside the range. You can use for interpolation, and to some extent that extrapolation also you can use. So I'll type the formula here equal to m is this slope into x is the temperature. Temperature I have not entered, so I'll enter it here. So m value into temperature, which I am going to enter here, plus c constant part will select, press enter. So it has calculated by taking the temperature as 0. So that is this value you got when temperature is 0. So temperature is something like 300. You will get the corresponding value 280. You are getting exact value. I need to interpolate. So I'll give some values which are not there. I'll give 290. I hope the 290 is not existing. 290. You are getting 284. This data is a perfect fit for a linear variation, straight line fit. That's why you are getting the exact values. When 300 I gave, you are getting 280. Let me give 200. 200. You will be getting 320, I think, in this case. So that may not happen for a real data. There is no error in the data. It is perfectly fitting straight line. So that's why for the recorded temperature, you are getting exact values of thermal conductivity. No deviation from the recorded value and predicted value. So that will not happen usually. Okay. So you can use this interpolation. 420 I'll give. So you are getting the corresponding 400. It's 240. 420. It's 232. So when the temperature increases, thermal conductivity is decreasing. So from here 240, the thermal conductivity is decreasing when the temperature increases. So this will give the interpolation values. Okay, so you can use the LINEST function to find out the slope and intercept, and also to interpolate and get values of dependent variable. I'll also use a LINEST function to produce additional regression statistics. To get the additional regression statistics for a linear interpolation, you need to select 2 columns and 5 rows. So 5 rows and 2 columns you should select. This is the required number of cells. 2 columns should be there and 5 rows should be there. So I selected that. After selecting that, you press equal to LINEST. LINEST function you can select. Then known y values you can select, comma, known x values, comma. Then third parameter you should select true. True means you don't want the y-intercept to be adjusted to 0. You want to get that y-intercept. So you should give true. It's false if you give the intercept will be set to 0 and then adjust the slope of that line. So I don't want that y-intercept to be 0. That is a line starting from the origin. So you can give true here, then comma. Again, return additional regression statistics, you should give true. So this also both parameters you can give true, then close the bracket. Here again, after typing all this, you have to hold down the Control Shift and then press Enter key to get all the regression analysis. So you are getting additional information here, slope and intercept you are getting. Then you are getting standard error of slope. So the error involved in the slope is here, and this is standard error for intercept. Calculating the intercept value, what is the standard error involved? And this is R square value. In this case, you are getting 1. Actually, R square value ranges from 0 to 1. As I told you, this is a perfect fit straight line. So R square you are getting 1. So R square, as I explained in the previous video, R square value indicates what percentage of variation in the dependent variable is explained by the independent variable. So here the variation in the dependent variable, that is thermal conductivity, is completely explained by the temperature. So it is a perfect fitting straight line in this case. And this is a standard error involved in the estimate of this data. And this is F statistics. It shows the overall significance of the model. Higher the value of this F statistics, it is better. Prediction is much accurate. And this is a degrees of freedom. So degrees of freedom is calculated as number of variables. So in this case 10 is there, minus 1 minus the number of independent variable. So here independent variable is 1. So 10 minus number of independent variables minus 1. So that will give 8 degrees of freedom. More number of independent variable, the degrees of freedom will decrease for the given set of data. So in this case, the number of degrees of freedom is 8. And SSR is a sum of the squares of regression from the mean value. And this is sum of the squares of the residuals. Most significant data in this analysis is slope, intercept, R square value, and F statistics. These are the most significant values. That's all in this tutorial. Thank you for watching.